Okay, I'm recording. It's the 31st and my webcam is working, but any moment it might freeze and I'll keep going because the microphone will still be okay. Today we're not assigning anything new, but we're going to look at the age calculation project. If you've turned that in, I'm going to take a look. It says 3, but it's really a lot more because some of them that I've got I've sent back with comments. And then the looping. We only looked at the beginning of that, and I want to see more deeper into it today. So let's do that. I think I got it ready to go. We looked at while loops, and those are pretty similar to the if because they have a true-false thing. You say if and then some kind of expression that's going to resolve to true or false. For while, you say while and then some kind of expression that's going to resolve to true or false. But with these guys, it's a little different. So let's look at one of the for loops. I kind of like this one, counting 10 to 100 by 10s, because there are lots of ways to do it. I mean, theoretically, for any of our exercises, there are infinite ways to do it. But for this one, it's kind of obvious. So write a program that prints out 10 to 100, like 10, 20, 30, 40, etc. Okay? It doesn't say how. It doesn't say what kind of loop or what to name the variables or anything. So that's cool. But we want our output to be like 10, 20, 30, 100. Okay? We could do it with the while loop. Like we have, maybe you've been doing those in the previous exercises and you're comfortable. So maybe you want to say while x is less than or equal to 100, we're going to print x and then bump it up, which means we got to start it somewhere. And that would work, okay? If I hit run, unless I type something wrong, that'll go 10, 20, blah, 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 all the way to 100. But that's not really what we're looking for. This is in the for loop section, and a for loop would do the job a lot better because this is a bunch of lines. Come on, it's too much. It's ugly. So we could do it with a for loop. Although if you did this, it's fine. No problem. But let's look at some other ways, because I think in this class it's important to realize that you're not looking for like the one right answer. It's not like this code is perfect and any deviation is wrong. This code works, but other code would work as well. And like I said, theoretically, for any exercise, there are infinite possibilities. So let's say you want to do it with a for loop instead, just to see what happens. Okay. Oh, by the way, let's see. Let's always look at their little test cases just to see if they like it. Yeah, okay. They like it. They're being very unpicky on this one. It just says you should use a loop. It doesn't say what kind. And you should print this stuff. It doesn't worry about it. Okay. So let's say we want to use a for loop, because this is in the for loop section. It seems like it might be a good idea. How do we do that? Well, sometimes after a for, you're going to consult some variable, like if you asked the user how many times do we need to do this or whatever. But in this case, they told us we need to do exactly whatever, this much. So you're probably going to use the term range, okay? For range 10, because we're going to do a thing 10 times. Maybe you print like x times 10. I don't know. We need our x in there. For x in range 10, print x times 10. This means it's going to go each time and print something. And this is not quite going to work. If you see what happens when I hit run, you'll see it's a tiny bit off, but it's pretty close. And look, it's a lot simpler than the while loop was. It's half the number of lines, right? Oh, we're so close. Look at that. We're so good. But when you do range, or when you do anything, if you're doing an index of lists or whatever, computers like to start with 0. So when you say range 10, a human mind might think 1, 2, 3, 4, but a computer actually goes 0, 1, 2, 3, 4, up to 9. Okay? So we could say, all right, I'm just going to do +1, you know? And that'll work. That'll get us a nice one. And if I hit test cases, the computer would like that, I'm sure. Yeah, and that's 2 lines, but that's a little bit ugly. I don't like this because if I was looking at it at a glance, I would think, what? Wait, why? Who? What? I would be a little bit thrown off by like, why are we adjusting it? Why did we do this range if we're not actually using the index in the right way? So I don't love that. But again, it does work. So there's another thing you can do with range, which is, I'm going to change this in a minute. Another thing you can do with range is tell it the start and stop. Instead of saying we're going from 1 to 10 or 0 through 9, you can say we're going from 10 to 100. And if you add another parameter, it tells you how much is in each jump. So you could say we're going 10 to 100 by 10. We're going from here to here, and this is how much is in each step. Now let's see what happens if I do that.
Teachers, pardon the interruption. We need the following students to report to the Marshall Center. Anthony Hampton.
Hey, are we back? Nope, my webcam froze.
No.
But audio's still okay. Let's just try it. Let's just move the webcam out of the way. Okay. So we are looking at this, and I said you can go what they call start, stop, and step. They've got some nice alliteration in the parameters here. And if I hit run, it's almost going to work. Okay, remember, just like last time, we were like range 10, print x times 10. It was almost there. This one, it's almost going to do what you think it is. But if I hit run, it's going to go 10, 20, blah, 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 up to 90. Why is that? Because when you give the range, it treats the top as like a less than, as opposed to a less than or equal. You know, like it doesn't hit it. It's exclusive as opposed to inclusive. So if we want to go to 100, we have to put like 110 or 101, you know, and then it'll hit the 100 instead of being excluded. So if I do this, it works. Is it going to like this on my test cases? Yeah, it is. Okay, so we've seen 3 different ways to do this loop, and you could do others. And you don't have to use x as your variable. A lot of people use I standing for iteration. Or you could say something actually meaningful. You could say like count or whatever, you know. So I wanted to show that one because it was so open-ended and because you can do many possibilities. But for all of them, you could do many possibilities. You're not just looking for a perfect right answer. Okay? Now, let's keep going. I wanted to look at another one because there's another one I kind of think is interesting. It is this guy, the average test score. And this says, hey, we're going to get some test scores. The user's going to type like, 50, 70, 80 or whatever. And then we're going to tell them the average. Okay? So let's look at the assignment real quick. You get an input, and you should only have one. Okay? We could just say, what's the first test score? What's the second? What's the third? And have those as separate lines. But that's really ugly. It's really inefficient. And it's really hard to change. If we wanted to change something, we'd have to go and change every single one instead of just changing the core thing that we're looping around. So let's see what we can do. We know that's going to be in there, so let's type that. It's not actually going to be the first line. But you never write top to bottom. You never write like down the line. That's okay. I'm just putting this in the middle-ish. Let's say score equals input enter a score, and then we're going to put int wrapped around that because we're going to be treating it as a number, doing some addition and division with it. Right? That's classic. We've been doing that for a couple weeks. That's not too crazy. And then there's going to be some kind of loop for blah, blah, blah. And then this is going to be indented to show that it's under the umbrella of that loop. And then afterwards, we're going to say average equals total divided by 3. I'm just making these up. I haven't created these variables. I'm just saying here's the stuff we're going to need. And then we'll kind of dance around it, adding what we want to do, you know. And then we're going to print average. Like this is the stuff that it was asking for in the assignment. Now how are we going to get it to happen? Let's see. For what are we collecting these scores? Well, it's just 3. Okay, they make it easy on us. We don't have to ask how many. We don't have to go until a certain thing happens. We don't have to check if the score is actually reasonable. We just say, doing it 3 times. So that's nice. On the other one I said x, let's say I, but it doesn't matter what we say. For I in range 3. And we get a score, and then what do we do with it? We got to add it to the total. So I'm going to go total plus equals score, meaning take the total and bump it up by however much that thing was. Now, we still need to set the total to something to start off with. So let's say total equals 0. And that means it's going to loop 3 times. Every time it's going to input, add it, input, add it, input, add it. Get the answer, print the answer. Is that going to work? I think so. Let's see what happens. We got a low one, we got a pretty good one, and we got a perfect one. Hey, it worked. I didn't even have to get into the weeds with types. You know, like this is an int. This should probably be a float because it's not going to give you the whole numbers every time. This one did because I aimed for it. But let's say we're going to get an ugly one. Let's say like 50, 75, and 75. This one's going to give us lots of decimals, but it knows what the deal is. And then print, we don't even have to say str because it's not being concatenated with other stuff. If we were being careful, we might say like float average and str average, and, you know, really get in there. We might want to round in order to make it look pretty because we probably don't want to have like a dozen decimals, but that's not what it's asking for. Let's see if they like that on the test cases. Hey, they do. Okay. But I want to show you that this doesn't actually have to be exactly this. We can mess around with it and do it in other ways. For example, we don't actually use the score variable. Like, we don't care about the individual scores. We're not saving it as like score 1, score 2. It never uses them later. It's never like, hey, what was that third one we typed? It's just dumping them in the total and then never looking at the specifics. So you could, I'm not saying you should, but you could skip this thing entirely and just say, hey, get an input and add it to our guy. And that saves us a line. It's not actually better because it might be more visually appealing to see that, hey, we're getting a score and we're adding it. That makes a lot of sense. But I just want to show that in theory, You could do that. You could also do this and make this a single line. You could also just put this in here and not make an average, just divide it when you need to divide it. So this theoretically could be 3 lines. Just want to show you that it works. And let's use the same numbers as last time to show you that it gets the same result. Is it going to like that? Yeah, probably. Hey, it does. So theoretically, this could be 3 lines. I'm not saying you should do that. This is, in fact, kind of weird because when you give things names, it makes sense to be like, oh, yeah, that's the score. We're using it. That's the average. We're using it. The only reason I showed you that is to show you that, hey, there's not one answer. You can mess around. You can make it a little shorter or a little longer, a little more specific, or a little more crammed into one big chunk. And that's okay. You're never just trying to hit a certain exact answer. You're trying to get a thing that does a job, and there are lots of ways to do a job. Now, you still want your variables to make sense. Score, average, total, these are very reasonable things. If I called them just A, B, and C, that would be ugly. So now we've seen an example with a couple different kinds of loops. We've seen an example where we can squish it around in various ways. And today, I'm going to give you time to work on that. I'm going to give you time to work on that assessment as well if you have turned one in or if I'm looking at yours. By the end of the week, everybody will have an assessment grade, including, by the way, a 0 if I don't have anything. And next week, we'll probably be doing a lot of parent contacts, a lot of like checking in on people who are behind or sending stuff back if it needs to be fixed, things like that. So we'll see how it goes.